Question 2. Let S be the shaded regions bounded by the graph of the polar curve R of theta equals 3 plus 2 sine 2 theta plus cosine 2 theta for theta between 0 and pi as shown in the figure below. It can be shown that R prime of theta equals 4 cosine of 2 theta minus 2 sine of 2 theta. Question A. Find the error of the region S. Show the setup for your calculation. Alright, so you know that the error of the region bounded by a polar curve R theta on the interval from alpha to beta is given by the formula. So we just plug in values 1/2 interval from 0 to pi, right here, of this guy right here, square, right? Now we're gonna bring up the calculator. I'm gonna copy this guy down over here. Press Ctrl Enter. It's gonna be 36.128. Then you need to divide this guy by 2, right? Or I'm gonna multiply this guy by 0.5, right? It's gonna be 18.064, right? Question B. There is a point on the curve at which the slope of the line tangent to the curve is -3/7. At this point, dy over d theta equals 3√2/2. Find ds over d theta at this point. Alright, so you know that the slope is going to be m equals dy over ds equals -3/7, right? So we have dy over ds is the same thing as divide the top bottom by d theta, right? Because we need to use this information, right, to find this guy, right? So it can be dy over d theta divided by ds over d theta. It's gonna be 3√2 divided by 2 divided by ds over d theta, right? So ds over d theta equals 3√2/2 divided by dy over ds, but dy over ds equals -3/7, right? So we're going to multiply this one reciprocal. It's going to be -7/3, right? So we're going to simplify 3 and 3 cancel out. It's going to be -7√2/2, right? Now question C. Find the value of angle theta in the interval 0 to pi/2 at which the radius has a critical point. So you know that a critical point occurs where r prime of theta equals 0, right? So we have 4 cosine of 2 theta subtract 2 sine of 2 theta equals 0, right? Now we're going to add 2 sine of 2 theta both sides, so we're going to divide both sides by cosine of 2 theta. It turns out to be tangent of 2 theta equals, right? And divide both sides by 2, it's going to be 2, right? Then we have 2 theta equals a tangent of 2, right? So theta equals 1/2 a tangent of 2, right? Now we're going to print up the calculator. Hit Ctrl Enter. It's going to be 0.554, right? Now question 2i. Use a derivative test to determine whether the critical point is the location of a relative minimum or relative maximum or neither for R, right? So we're going to take the second derivative of R of theta, right? So it's going to be -4 times 2 of sine of 2 theta, right? Minus 2 times 2 cosine of 2 theta. Simplify this one, it's going to be -8 sine of 2 theta minus 4 cosine of 2 theta, right? Double prime of 554, right here. So we just print up the calculator, enter. It's going to be negative 8.944, right? Which is less than 0, right? So by the second derivative test, since r prime of 0.554 equals 0, right? And r double prime of 0.554 less than 0, right? The critical point is a relative maximum. Now question D. Find the average distance from the origin to a point on the polar curve. Alright, so we have the formula of the average value. It's going to be, now the interval is right here, and this is A, this is B. So it's going to be 1 over pi minus pi over 2, right? Interval from pi over 2 to pi, right? This guy right here, right? Now previously I already used this guy, right? So I just copy this guy down over here. Now I just change the upper bound and lower bound, that's it. And don't forget to remove the square right here. Pi subtract pi over 2, which is pi over 2. 1 divided by pi over 2, which means 2 over pi, right? So I need to multiply this guy by 2 over pi. And then press Ctrl, Enter. It's going to be 1.727, right? Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.